Here we go. Let's go into today's session. So thank you for joining us. As I say, as you're all aware, CYP then are well known for signal distribution products. As you can see on screen, they're covering AV over IP, HDMI and HDBaseT matrices, extenders, a wide range of extenders. We've got our audio products, including converters and amplifiers, switches, presentation switches, HDMI switches, converter products, so video signal conversion, signal management tools as well, and then things like HDMI cables, and they can be used across a range of applications, as you see along the bottom there. Today we're going to be focusing on our 10 gig AV over IP solution. First off, we're going to have a little recap on the 1 gig system, the slightly more cost-effective 1 gig system, and then we'll move on to why you might want to upgrade to a 10 gig system in certain applications. Let's have a quick look at the 1 gig solution. So our IP7000 AV over IP system then is converging video up to 4K 30 444 or 4K 60 420, so a 3G solution, covering audio, power over Ethernet, control signals and USB functionality. And that's based around our IP-CS8 controller, the IP7000 transmitter, the IP7000 receiver, and all of that is then over a 1 gig network switch. So again, quite a cost-effective option for this sort of system. And why might people pick this sort of system? It's basically flexibility and scalability. So you can always add transmitters or add receivers to build that system up later down the line. Got the control system, which uses the simple drag and drop interface. It's very easy to use. It's simple to set up because it has a setup wizard built into the controller. That's the controller you see at the top of the screen there. It can be run as a matrix. It can run just as signal distribution. You can set up video walls. You can set up group screens, and you can set up different logins as well. And because this system's on a 1 gig network switch, it's very cost effective. So you're probably thinking, why would we need SDVoE? Firstly, just to clarify that SDVoE, it's software-defined video over Ethernet, and it's an alliance. So there's multiple companies joining in with this format. Why would you want SDVoE? So the main thing really would be these points: high bandwidth with support for 4K HDR and 4K 60 444, so you can get a much higher bandwidth through the SDVoE system. Very low latency, incredibly low latency through the SDVoE system as well. Ultra fast switching, which we'll cover as we go through, but switching from source to source can be incredibly fast. We were demonstrating this at ISE, and it is literally lightning fast switching from source to source. Multi-view capabilities, which we will go into shortly. That's the ability to show multiple transmitters on one receiver. And then we have options for fiber in the SDVoE system as well. So as you'd expect, you get the key benefits of fiber, such as long distance, no electromagnetic interference, for example. So all the benefits of fiber connectivity as well. Let's have a look now at some of the hardware in this SDVoE 10 gig system. So comparing the two systems, on the left-hand side there, you see the 1 gig solution, IP7000s that we all know quite well now. And then on the right-hand side, you've got the SDVoE system, and that then is your 10 gig option. As you can see, the key benefits there really are 1 gig versus 10 gig. So again, you've got much more bandwidth to play with. That then allows you to have lower latency, or part of the SDVoE system is lower latency, so much lower latency across the system. And because of the higher bandwidth, you can then pass higher quality signals like 4K 60 or 4K HDR. And as I mentioned, the SDVoE system is available in fiber or capped versions, depending on what the application requires.
I think the thing to remember as well is that the overall picture quality, because you've got so much more bandwidth to play with, that even at 4K 30 or even 1080p, the overall picture quality from SDVoE, as you get higher up the resolutions and timing, the overall picture quality improvement gets more and more. So it's not only just that it's got greater support, but actually the overall picture quality, especially when you get to 4K, is vastly improved.
Fantastic. Yeah, thank you, Kev. Let's have a little bit of a look now. So these are the main two units that we talk about most of the time. These are our transceiver products. So as many of you are probably aware, that's then a transmitter or receiver. You just assign the function of the unit as a transmitter or a receiver within our control interface. On the left-hand side there, you can see the CTRX. So that is, if I just quickly highlight that there, C for cat, and then TRX as in transmitter receiver, TR. So that's the cat version. And then on the right-hand side, you've got the FTRX, which is then fiber transceiver. Again, both of these are available. They're both current models, but not everybody would need the features of fiber. So you might be happy with a cat system, just obviously that's going to be a slightly lower cost, and you won't then use, for example, a fiber network switch. You'd use a traditional network switch. Looking at the CTRX, this is then the back of the cat version, and that would be up to 100 meters transmission distance either side of the network switch if you're using it with a network switch. And again, as I mentioned, that can be configured as a transmitter or receiver within the control interface. Sorry, just skip back there as well, and that's HDMI in and out. As
so
we move up.
Those additional, obviously it's designed as a transceiver, so you've got HDMI in and out. But actually, they both perform a function whatever mode you are in. So if you're in a transmitter mode, the HDMI output is then used as a local monitor output of the signal that's coming into it. And when you're in receiver mode, the HDMI input can be used as a local input source. So it's offering flexibility as well there.
Fantastic. Yeah, brilliant stuff, Kev. Thank you.
It's the same for the fiber version as well.
And the audio as well. Do you want to cover that while you're there? Because that, again, the audio connection on the back there.
Yeah, so SDVoE, when you're in the transmitter side of SDVoE, the audio jack, you notice there isn't labeled as in or out. That's because in the SDVoE system, when you're with a transmitter, so in other words, a transceiver that's in transmitter mode, you can decide whether that audio is an input or an output. So input, you just use it as a standard audio just to get the audio across the separate audio stream. But if you have it as an output, then you can actually, it will de-embed the audio coming in from the HDMI if in fact that is stereo audio. So you've got dual functionality there of the audio. In the receiver, it's just fixed, but in the transmitter, you can actually decide which way that audio actually goes.
Fantastic. Yeah, thanks, Kev. Moving on from there, so that's the cat version. And then as you move up, you've then got the fiber version. So this then adds the DisplayPort input as well. Not an output, but DisplayPort input. And then you've got, so on the fiber models, we'll show you in a second as well, the module that we're talking about. But as standard out of the box, these fiber models can transmit up to 300 meters using the supplied fiber module, the SFP module, and OM3 fiber cable. If you simply change to OM4 fiber cable, you can then up that to up to 550 meters. Or if you actually then change the fiber module, which we're showing you a picture of now, that's the area on the back of the unit highlighted in green, you can then get much longer distances. Do you want to quickly go into single mode at all, fiber, or anything?
Yeah, I mean, just to say that obviously there's different of these modules. You can see from the example image there that the modules just literally pull in and out from the actual unit. So they just slip in and out exactly the same way as you would find on a network switch hardware. And obviously, if you do need to go ridiculously long distance, you can get single mode fiber modules that are more expensive. I mean, your average multi-mode one is, could be as cheap as £30–40 retail. But obviously, the longer transmission distances you get with single mode fiber, the more expensive they are. And obviously, you need a different type of fiber cable. But it's very easy to get transmissions up to 10 kilometers through that. So if you've got to go, we've done it from where we've gone from one university's building to another university's building across a fiber link. I mean, they already have the fiber link laid. but it just went across the site from one building to another. So it does provide a very good functionality. And as far as the SDVoE system is concerned, it doesn't change. It's exactly the same whether you're, 2 meters away or 10 kilometers away. The whole system operates in exactly the same way.
Super, excellent stuff. And then just quickly looking at the controller, so the SDV-CS8, many of you are probably familiar with our CS7, which is the 1 gig unit. In terms of the look, this actually looks very similar, the actual hardware, and for using it, it operates in a similar way as well, in terms of this, for example, on screen. If you wanted to use it with a touchscreen of some description, then you can connect the controller directly to a touchscreen with the HDMI cable for video and the USB cable for the touchscreen functionality. You can simply plug directly into the back of the controller our CRTG1 trigger keypad. So if you have set up any presets, they can be recalled through this trigger keypad. And there are then third-party options as well, aren't there, Kev, for control if you wanted to access it other ways?
Yeah, obviously, like the IP systems, all of the commands to switch stuff around are available via Telnet and RS-232. So if you're using a third-party control system, you can just send the switch data into the CS8, and it will then switch it as if you're using it via the web GUI or any other control methodology. So they're pretty easy to set up in that way. So if you're using them with Control 4 or Crestron or something, you can do that quite easily.
Fantastic. One thing we didn't say at the beginning, by the way, if anyone does have any questions throughout, feel free to just use the Zoom chat feature. Just pop a message in the chat feature, and Kev, most of the time, he's the one with all the know-how. It normally just be able to ping back some replies there, or we'll hopefully have a little bit of time at the end for some questions as well. Let's have a look now at, again, some key features of SDVoE versus other systems. So again, reasons why you might specify this. So the transmitter, when the unit is in transmitter mode, essentially it's creating multiple streams. This part can get quite advanced, but it's got a lot of flexibility. So I'll probably let Kev run through this a little bit more in detail now. I start firing up some images on screen.
Yeah, sorry. I was doing just exactly what you were saying I should be doing.
I was trying to see whether you could multitask. You know, they would say men can't multitask.
I'm a man.
Loading you up with stuff.
I can't possibly do that. Right, yes. So the primary stream. So yeah, we have various streams that are going on here. You've got quite a lot of them going on. So you've got the primary video stream, which is your fullest quality video that you can get. So that will include your 4K 60 and the stuff like that. And then you have a multi-view stream. The exact nature of this stream will depend on how you set up the multi-view, or the quality of each image. So if you've got, the screen split up into 16 segments and the overall frame is a 1080p frame, then obviously each window is, what's that going to be? 720p individual picture inside it, and that is actually created by the transmitter. So the transmitter creates that substream at the same time. And then you will have a video wall substream. Now, strictly speaking, this is actually part of the primary video stream, but it feels like another stream. But actually what's happening when you have this video wall set up is the video wall settings engage the scaler on the RX to create the scaled image to fit the video wall environment. But further to those, you've got HDMI audio, analog audio, USB, IR, and RS-232. So you've got quite a few streams going on. Now, SDV are working at the moment on even creating more versatility to these streams. Their new AVIP chip, I think they've called it, actually has some further analog audio streams that are coming back the other way, that allows you to be a bit more flexible with the audio. This is partially from feedback from us and our market and you guys, just about getting audio return from the TX back to the RX. So that is going to be included on the AVIP chipset, which we're working on with them now. So the network switches there. So I think if you've been on any of the AV over IP 1 gig solutions, you'll realize that those network switches need a little bit of configuration. But actually with SDVoE, the 10 gig network switch doesn't need any configuration at all. There's actually a virtual server that is running on the SDV-CS8 that integrates and does everything that needs to happen on the 10 gig network switch. So there's two things to remember there. You don't need to do anything to the network switch, but unless you're point to point in the system, you need an SDV-CS8, even if you're not using it for control. You need it there to manage the 10 gig network switch and manage all the interfacing between that and all of the SDVoE products. So unlike IP, where strictly speaking, you could put a bunch of TXs and RXs in and address them individually, individual IP addresses for each unit, you cannot do that with SDVoE. You must have the controller in the setup. So then obviously that's the input side, and then the output side, you get your output streaming to your receivers. So it receives the relevant streams, whether it's multi-view or primary streams, and then displays the images and gives you the audio and the USB and IR that you need, that you've selected for the streams.
Wonderful. There we go. And just to highlight now on the multi-view that Kev mentioned with one of the multi-view streams. So just to try and put that into sort of a real life example, or just a better illustration, that would be having multiple transmitter streams across the network, through the network switch, of course, and then displaying all of those transmitters through one receiver on one screen. So instead of in the past maybe having to get a separate multi-window hardware or a picture-in-picture box or something similar, you can now do that through all of the receivers on this system. And that can be mix and match as well. You can have one receiver showing multi-view, as we've shown it on here. You could have another receiver that's just showing a standard image. You can have another set of receivers in a video wall configuration. You can really mix and match what you're doing with all of these different streams. And just on screen there is just a handful of examples of the multi-view presets. So you can just select any of these and then populate. So you see on the right there, you've got an example there with about 13 different screens.
Is it 27 different ones or 23, something like that?
Yeah, it's high, isn't it, Kev? And you can select from anything from a side-by-side, just literally 2 transmitters, right the way through to sort of 15 to 20 different transmitters all on one screen. I don't know the max. I know the maximum we've got on here is about 13, but there's another drop-down page, isn't there, of these? So can fit a lot. Maybe CCTV or something. Somebody could be using a lot of transmitters, all being displayed on that one central receiver.
Yeah.
We'll have a bit of a look now at a case study of a system in action using SDVoE hardware. And that's this. So it's the Zurich Opera. So they had a system, they really wanted to show multiple of their actors on different screens, but obviously with no video to audio delay. With this system here, they're actually running that with large projectors. But again, of course, they needed picture-in-picture, they needed certain features not available through maybe mainstream hardware. So one of the key reasons they chose SDVoE was to get this live camera to screen. So of course you're filming an actor and you're showing that screen, you're showing that image on a screen in the background, but you don't want any lip sync or audio delay. So using the incredibly low latency of SDVoE, you're able to get that image from the camera to the screens in incredibly fast time. So then it all matches up, it synchronizes nicely. Moving on from there, you're using the flexibility of the SDVoE system to give you those multiple screens around the Opera. So as you'd expect, you've got your transmitters, you've then got your 10 gig network switch with the CS7 controller sitting over all of that. And then on the right there, hopefully you can see that I've got a picture of Kev on the top right of my screen, so I can't quite see that image on the top right. But you've got one of those receivers that is running as a standard single screen, just showing one display. you've then got a second unit showing picture-in-picture. So one of those receivers is showing two different transmitters on one receiver, so a picture-in-picture configuration. You've then got another receiver that is actually then showing multi-view, so that's then showing them 4 transmitters in one receiver. And then you've got a set of 4 receivers showing a video wall configuration. So again, all using the SDVoE, the CYP hardware there, you've basically got a combination of single screens, picture-in-picture, multi-view, and video walls, all running with those key features we mentioned, the high image quality and incredibly low latency. And just highlighting that on the bottom right there, again, those main key features, incredibly low latency. You can have the incredibly fast switching time as well, or seamless switching. Kev will go into that a bit later on. Multi-view and picture-in-picture, as we've said. The control system is a doddle to use. If any of you have seen our IPCS7 where you drag and drop, this works very similar. Just drag and drop the transmitter to the receiver. And then as it says there, 4K 30 uncompressed and 4K 60 transmission over the system. We'll now go into the web GUI a little bit. So I'll hand you over to Kev to run through some of the key features of the CS8.
Thanks, Dan. So again, as you can see, you've got the general drag and drop ability there. The SDVoE system originally started without having any screen grabs. And over the last few iterations of their firmware, they've enabled it firstly on the transmitters and then on transmitters and receivers as we've moved forward. So you now have, for the vast majority of types, obviously not for multi-views and presets and video walls, but you will see those captured images of your live streams going on. And then you can just drag and drop them as normal. So as we can see along the top there, we've got many, many more sort of streams going on. So the important things to remember here is that you can address these streams individually through the CS7, but also you can get, for example, commonly you want the HDMI audio to follow the HDMI video. So there's a way of very simply, in fact, the default settings on this is the audio, the HDMI audio will follow the video. But there's ways of managing this so you can get everything to follow at the same time. So that you with those streams, we'll go into them a little bit. So the things to remember here is you've got the streaming stop button at the bottom here. So you've got this is the ability to stop a stream. So you have all stop, native stop, and multi-view stop. So this is just the if you like 3 different options to stop streams. So if you've got a stream going on, you just quickly want to stop the transmitter streaming it, you can do it there. If you hit the arrow button, the circular arrow button, that will flick through from all stop, native stop, and multi-view stop. So the native stop is just what they call their primary stream. So in the HDMI, you've got independent HDMI audio routing. Also, all of these streams have a similar stop function. So you have a similar drag and drop functionality until you get over to video wall and multi-view. So again, for USB and RS232, you have the same type of thing going on with drag and drop multi-views. For the video wall, you can select some predefined video walls. So you're still dragging and dropping, but you're dragging and dropping to predefined video wall presets, and the same for multi-view. But as you can see from the video section at the front, you get the multi-views and the video wall set there as well. And then you've got a macro section. So that is just where you set up your macros. So in other words, multiple transmitters to multiple receivers to recall them all in one easy method. So really next, I think it's important just to go through some of these icons. I think we've got that now, haven't we, Dan?
We have, just after this wonderful graphic. There we go.
Oh, yes. Look at that.
You can't miss that one. You can't miss that one.
No, I mean, your PowerPoint presentation work is now beyond my paint, my Microsoft Paint drawings now.
That is saying something. I appreciate that, Kev.
Yeah, no, it is. My paint drawings are legendary.
They are.
Okay, so yeah, just to quickly run through some of the icons that you're seeing there. So as you can see, you've got a symbol for video wall, a symbol for multi-view. So this is because when you've got the live screen grabs, obviously you can't show a live screen grab of a video or a multi-view in the same way you can as a normal transmission stream. And then you've got no signal. So this is when this tells you that the transmitter can't see a live source. So either your source is not on, it's disconnected, or perhaps you've selected one of the other inputs, but it tells you what you're actually, the transmitter is not actually seeing a source right now. And the reverse for the not connected, this is when the receiver doesn't see a TV, so it can't see an HDMI sync on the other side of it. So again, quite useful for when you're setting up a system and when you're putting a system in for the first time to know that that's not producing a picture because it's not connected. And then the support displayed when the transmitter or receiver can't support the video thumbnail feature. So occasionally you get things where they're odd resolutions that the system can do, but the thumbnails can't. Quite rare, but it does happen. And then you get the warning triangle. So this is displayed when the transmitter source streams, this is the important bit, collectively over the bandwidth limitation of 10 gigabits per second. So you actually, there's actually another warning symbol that I can't remember what it is, and we don't have it here, that tells you it's getting close to the 10 gig. So what we've got to remember here is we have a bandwidth limitation, and the bandwidth limitation is actually the network switch. Even the fiber ports on a 10 gig switch are only 10 gig in, 10 gig out. So whilst the SDVoE hardware could, strictly speaking, stream stuff above 10G, it has to try and make sure everything's within 10G. So this tells you that actually you're going too far. So this can happen when you've got full 4K 6444 in both your primary stream and your multi-view stream. So when you're doing both of those, you can go over the bandwidth depending on what all the other resolutions are going on with the multi-view stream and how you're using all of the rest of the streams for that particular transmitter. And then finally, the offline. So this is displayed when the transmitter and receiver is currently not detected by the controller. So again, so if you've got a system and that pops up, it means somehow that TX or RX, whatever it's configured as, has suddenly not been seen on the network. So there's a problem there, but it lets you know. So they're quite useful to see those icons. Okay, so this is a standard control system settings page. Sorry, I was just looking that Ian's just asked. The CS7 and CS8 interchangeable. They are basically the same hardware. There's subtle differences in the hardware as things like, I think the CS8's got a bigger RAM stick, if you like, or bigger RAM. But we are working on the possibility of getting one unit that will work for many different systems, and you can just switch the mode. So presently, no, they're not quite interchangeable because they have bespoke firmware for each system. But it is something we're looking at, especially as we are planning to release some H.265 streaming products as well. There you go, just answer that one while we're here. Yes, so the system, so this is where all your system settings in. Obviously, you need to log in to this system in order to access everything. Like all these systems, you can use the monitor and control page without logging in. But if you wish to use or make any settings changes, you've got to log in, and then all of this will become live and not grayed out. So first of all, there we've got our LAN 1 and our LAN 2. So this again is indicating the dual LAN connectivity of the CS8. So again, the standard configuration is for LAN 1 to be your PoE input, and this is connected to the IP network switch that is all of your SDVoE system is connected to, and then LAN 2 is for your wider IP system in the premises that you're installing. So think about it as being the LAN 2 being how the system integrates to the wider network. So, for example, if your technicians are controlling this system in your business, they might want to access the CS8's web GUI from their normal laptop computer on your normal work network. So that's where you make the connection to the second LAN on the CS8. If everything's being controlled via the CS8 and via a touch screen, and there isn't, then there's no need to connect it to a wider network. But normally you connect it to a bridge. This also, of course, allows you to leave PC technology on site that you can log into, so that you can remotely access the entire system. So then we've got our standard login, log out, save, config, upload, config, password, and save log. So most of that's obvious. So the save config and upload config, that is just for when you're doing multiple systems of the same type, or more importantly, when you finish a system and everything's set up, you might want to download that config file and save it with your project data. So if anything were to go wrong, you can just upload it again. The change password is just to change your password settings, and the save log is primarily for support. So if you're having a problem with your system and you contact us for support, we may ask you to provide this save log, and this just gives us information about the system and what's happened in the system recently, so we can see if there's, try and hope we diagnose a problem with it. And then we've got some common resets. So you've got a factory reset of the CS8 itself, and then a factory reset of all transmitters and all receivers. Very useful if you've been training yourself by getting a kit from us and having a go at it, and you want to reset the units back into their default state to go back into your warehouse to sell on. And then we've got the firmware update. So again, at this stage, we have an update for the CS controller, CS8 controller, and then an update each for the transmitters and the receivers. So it will update them all in one go. So it will look at every single transmitter and every single receiver in the system, check what it's on, and update it as required, and reboot it and put it back in the system. So you can very quickly, at the end of a working day, if you're called into a business where this is you've installed this system, you can go in at the end of the day and just update, or in the morning before they come in, just update the whole system. It will build the whole system back up after the update and back to exactly the same state it was when you started the update. So very simple to firmware update and keep the system up to date. So going further through here, we have the settings. So this is actually the settings for the system itself rather than the actual hardware. So this is where we can set up our groups, our macros, our configuration for RS232 and IR, what we use, what we are triggering with our IO triggering, and then any bespoke EDID management that you want to configure there. So reasonably standard stuff. It's very simple to create them. All of these things are created in the same way. So if we look at the groups in front of us, so you hit the plus key, and that allows you to create a new group. You give it an order, which is just the order it appears in front of you there, and then you name it and you say what is it. So in that group section, you have basically, you're saying what stream is it? Is it all the streams? Is it the video stream, the audio stream, the HDMI audio stream, the IR RS232 streams? So it allows you to not only set up groups, but groups for particular sub-streams. And then you just name it and save the groups, and you have all of the groups on the first one in the middle there, and then the devices on the next one. So you literally are just deciding which groups are having which devices in them. So it's reasonably simple. So you just literally drag and drop the devices from the device section into the group section to make that group, and then you just save that group, and now all of those devices are now saved in that group. So it's very similar with the macros and RS232 settings as well. The triggers is just like a drop down where you decide what particular function, what setting is being triggered by the trigger, and then EDID just has all the TXs and RXs with some EDID presets in there as well. So you can always, if you need that particular source to be looking at a 4K UHD edit, you can either point it at a screen, or you can use some of the presets inside that are already provided for you. So going on to look at the transmitter tab. So again, we have our hello function, the first thing on the left there. So if you don't know what this does, is when you flick this on, you will get some of the LEDs on the front flashing. I'm trying to remember whether it was all 3 or just 2 of them. Can't remember. Anyway, they flash at you. So this allows you to identify the units, in the physical hardware units that you've turned this function on. It's quite a simple idea, but it's very effective when you're building a system, when you've got transmitters in the rack or you've got receivers behind TVs. You need to be able to identify these and label them correctly, or if you've labeled them already, you need to know which one's which so you know where you're putting it. So a simple little function, but quite nice. So there, you also then have the little icons there that tells you what's going on, and then you have the order. So the order is just telling you what order they are appearing in the monitor and control section. And then you have a visual of the names and the IP addresses. So that you can't make changes there, but you can make changes in the next section to those to rename them or change the IP address. So then we've got all the settings for the transmitters on the far right there. So first of all, we have the video info. So this tells you all of the information about the incoming video signal. So it's just telling you about the actual signal. What is its resolution? What is its color depth? What is its color space? Does it have HDCP? What's connected to it, and what resolution can that connected device achieve? So just a little bit of information for you about the incoming signal, so you can double check that. The same sort of thing for network. So it's worth mentioning here that I've said that you don't need to touch your 10 gig switch, but there you can see that the IP mode there is set to DHCP, and some of you will be thinking, well, hang on, that means don't I need to play with my network switch? Well, actually, no. The system's set up in such a way with the transmitters and receivers and the CS8 for that matter, that they will look and see if there's a DHCP being provided by the network switch. But if they do not see one, they will automatically, without you having to do anything or touch anything, they will automatically set themselves up for auto IP. So if you actually look at the IP address there on that system, it's a 169.254, which is auto IP. So even though it's set to DHCP, if you haven't enabled DHCP, because I've told you don't need to touch the network switch, don't worry, it will automatically assign itself an auto IP address. I guess I should mention, so auto IP is just a part of the IT infrastructure where if a product can be designed in such a way that it will automatically give itself an IP address if nothing else is giving it an IP address. And it's always this 169.254 something address. So it's an automatic way of getting an IP address. You will never, no 2 units in the same system will give themselves the same auto IP address. The system is intelligent, so you'll never get an IP clash there. So the RS-232, so this is just setting up the RS-232. So this is the actual what you are wanting to transmit. So you're transmitting from this piece of controller to this projector, and you need the baud rate, data rate, polarity, stop bits, blah, 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 to be this. So you're just setting that up to match the thing you're controlling at the other end. And then we've got devices. So this is telling you quite a bit of information. For a start here, you have the system command. So the system command is quite an important area because as we know, this is a transceiver device. So one of the things you'll find there is the transform function. So that when you get a unit, I think they generally default to TX, so they'll all be TXs. So you need to go into the system and just use the transform function on a TX, which will change it into RX mode, take it out of the TX list, and automatically put it into the RX list. So again, it's very simple to just change the units from there. You also get things like factory default and reboot in that command list as well. And then the name, so the name, that's where you can change the name. The default name of all equipment is always its MAC address. Now, obviously, you can change that to the source, you know, your PS4 Pro, which looks great through SDVoE, by the way. Not that I've done, you know, I might have tested it for a little while we were locked down. I might have accidentally finished Gods of War. And then there you have the audio port direction. So again, if I mentioned earlier that the TX, you can actually decide the port direction. So is that audio port an input or an output? When it's an output, D embeds. When it's an input, it provides you the separate analog stream. And then you've just got two HDCP supports. Again, both of these are just enabled. It's enabled in general. It's very, very rare that you actually need to use anything with those. With those ports, you occasionally, if you're using it with a Mac and you're going to a non-HDCP screen, you might want, well, you will want to disable those HDCP and HDCP 2.2, take them from enable to disable, because your Mac will start putting HDCP on the signal automatically. Some PCs do it as well, but that's the only time. So if you're getting a problem where you're connecting to a PC to a non-HDCP display and you're not getting a picture, just check those settings, and you might wish to disable that in case your computer is putting on HDCP as a matter of course, because it's seeing an HDCP system. And then we have divide frames per second by 2 mode. So there's a couple of grayed out elements there that you can see, that's because it's in auto. So this is a mode that we developed to CYP in case you are starting to go over bandwidth, or in case you go over bandwidth. You remember I said earlier that if you're sending a 4K 6444 primary stream and a 4K 6444 multi-view stream, you can actually go over, even though there is a little bit of compression being applied to signals here, you can go over the 10 gig limit, as you can imagine. So this automatic mode will recognize that for you and just do a frames per second divide in half to enable you to make sure you always get a picture. So it's quite a simple system. My advice is to kind of leave that on auto, and then if the system does go over it, it will do it for you. But if you can have a play with it and see what you think. But generally speaking, it does a good job of automatically protecting you from getting no signal. And then the IR routing paired. Now, this is to fix IR routing, so you can fix the IR routing to one RX or TX in that system. So then finally here, going on to USB. So this is just telling you the USB mode settings. It's all reasonably standard. It gives you an IP address. I'm just going to check my notes here because I know there's something I want to tell you here. So the most important thing there is the simultaneous mode at the bottom. When you enable this mode, up to 7 receivers can receive the USB from one TX. So this allows you to have one transmitter's USB connected to up to 7 different receivers, and there's an area later that you can play with that in. But the rest of it's reasonably standard. It's giving you the IP address and the IP mode and the system commands there as normal. So the receiver page for this is very similar. You basically get the same thing: the hello, the order, the names, the videos. They're all very, very similar, but it's worth just dragging out the device settings here. I think we do, Dan, because what we've got here is a few of the audio settings. So you get the same system command and the same name, and then you have HDMI audio source. So this allows you to change the audio to follow video in bypass mode, which is quite a useful function. And then it has the analog audio source. So this is asking you where you want the analog audio to take its source from. So is it taking it from the HDMI, or is it taking it from the actual separate analog audio stream? And then you've got HDMI audio follow video. So this is just the mode I was speaking about earlier, where when you're switching the video HDMI video stream, the audio from HDMI automatically follows it. And then the same thing for the analog. You can get the analog follow in different ways. So the analog follows RX, HDMI audio mode. So again, these are just ways of controlling the audio streams and where they're seen. And again, at the bottom there, you've got the IR routing auto paired. So this is where you make that enabled to fix that IR routing. The rest of the settings there are pretty identical to the TX page. So let's come on to the scaling page. So this is where it shows you all of the scaling options available for every receiver. So every receiver has its own scaler on board. It's a really high quality scaler. This is not some cheap budget scaling going on here. This is really, you know, some of the best scaling you'll see in the market. So basically you can just pick up an RX and drag it to your any timing you wish, so 4K 60 there, or you can do it with groups, or you can do it with all RXs. So one of the things to remember here is that two things to remember here. First of all is that the SDVoE system is a very low latency, so this of course helps switching time. But if you have the scaler on, your switching times will go from being fast to being really fast, absolutely fast. So what you're doing here is you're keeping the connected display, the connected TV, never knowing anything about the switch. So it always thinks there's a signal. So the signal is, as far as the TV is concerned, is always there because the scaler is keeping that signal active. So when you have the switch of a split second, and it really is a split second, you know, viewing it myself, it's faster than my Skybox is at changing channels from BBC One to BBC Two. You know, it's so fast. You know, you can hardly see a change at all. It just seems to flow directly in it. So to get this fast switching mode, you must have the scaler on. So what's the second point? Why wouldn't I want to do that? Well, the reason you wouldn't want to do that is because you cannot achieve HDR, true HDR in a system when you have a scaler. By definition, you break the color depth and the chroma subsampling that's going on in there. So you kind of have to make a choice. Now, of course, you can make hardware that has a scaler on it that you can get the HDR logo to flash up in the corner. But if you look at it, it's not HDR. It doesn't have Rec 2020 in it. And yes, okay, you can get a little bit of metadata to pass through to make the screen flash up HDR. But that's just a bit of metadata. It's not HDR. You cannot have HDR and a scaler in the same system. So you have to make a choice. Either you want ultra fast switching in your system, or you want HDR. Or what more commonly happens is that room over there, which is say your cinema room, you don't have the scaling on. You're only using it to watch films. So if it takes 3 or 4 seconds for it to switch from your PlayStation to your media server, it's not the end of the world because you want that HDR signal coming through. And then maybe if you want something that's in a normal room, either a business premises or a lounge or something, and you just want bang, bang, bang fast switching, just put the scaler on. Again, what you really should be doing is matching the scaling setting to the TV. So if it's a 4K 60 Hz 444 TV, you set it to 4K 60. And that way you're matching that up and you'll get that incredibly fast switching time. Great. So the video wall. So the video wall here's where you set up the maximum video wall. So the maximum, I think, did we say it was 8x8? I think it is 8x8. So I believe that's just I believe that's actually an SDVoE restriction at the moment, 8x8. So I'm not sure whether there's any further development there, but at the moment that's as big as you can go. But that's pretty big. So again, you do the same thing. So to create a new video wall, you hit the plus button at the top, and then you can give it its order, its size, its name. the default transmitter. So this is not the transmitter this video wall has to use. It's just the transmitter you're using now. The overall display resolution, the aspect ratio, and there's a little bit of bezel control there. And then once you've set that up, so here we've got our 8x8. So then in the receiver section, you would have all of the receivers listed. Obviously, we've only got half a dozen here, and most of them are hidden. So you know, if you had 64 units here, receivers, you would see all 64 in a big list. And again, you can just pick them up and you drag them to the spot on the video wall that you want them to go to. So very, very simple. Once you've done that, you can save the system, and you do have an execution button there to make that live straight away. So whilst you're on the video wall, you can see it set up, because then you can make the minor bezel corrections you need to make, which are applied across all of the screens. So it is expected that the screens are the same make and model number, that have the same bezel, that will require the same bezel correction. So yeah, and then you can just make as many as you like, any size you like. So it's very similar with multi-view. So you have all the multi-view options in the middle there, and there is 27. I've looked down at my notes. It says 27. So there's 27 different arrangements. There's lots of different options, from just a standard picture-in-picture to 16 different images on the same screen. So you just do the same thing. You use the plus button to create a new one. You give it an order, so the order it's appearing there. You give it a name. You decide the base transmitter. The base receiver. So again, this is not the receiver this multi-view always has to go to, but it's the one you're testing it on when you configure it. And then you give it a display resolution. And then at the bottom right hand corner, you can see here you have the transmitters. So you just do the reverse. Instead of dragging the receivers to the video wall position, you're dragging the transmitters to the position in the multi-view you wish them to go in. So once you've dragged them across, you can then hit execute, check the system's working, and then save it. So in that way, you can very, very simply, and once you've done it a few times, it literally just takes a few seconds to set up a video wall or a multi-view. It really is very, very simple. And as you can see here, you can have very simple picture-in-picture as well as more robust and bigger multi-views.
Wonderful. I think that covers the GUI, doesn't it, for now, Kev? One thing I thought of that we didn't actually mention then, of course, what you're seeing on screen could be viewed directly from the CS8 if you've plugged it into a screen through the HDMI output, or what you're seeing on screen can also be accessed through any device on the same network with a browser, effectively. Laptop, tablet, touchscreen, well, effectively, yeah, anything that can access the IP address of the controller can be looking at this same control interface.
Oh.
I'll just quickly bring up the codecs for you, Kev, if you wouldn't mind doing your whistle-stop tour, and then we'll do a wrap up our little summary, I think.
Yeah, sure. Sorry. I could have just said this in this time. Yes to everybody. Okay. So we're just showing you 3 different types of AV over IP systems. So your older 8.264, which basically you don't really need to use very often, but 8.265, that can be quite useful. You know, there's use for those systems if you've got older CAT infrastructure, or actually it's more about just getting the picture there. What's also useful about 8.265 is you can do a closed network streaming like IP or SDVoE, so a closed point-to-point TX to RX streaming matrixing system, whilst at the same time streaming it out to a streaming service like Twitch or Facebook or something. I struggled to say that word. So it does have its uses, and we are looking at some technology at the moment that will help that. And then you have the AV over IP system, which uses the motion JPEG, and then you have the SDVoE system. So as you can see here, as far as bandwidth goes, the SDVoE system has vastly more bandwidth available than anything else in the system. Now you can see that it's listed for 9 gigabits per second there. That's because we, SDVoE reserve 1 gigabit per second for all the other streams and all the other networking that's going on. So it has vastly more bandwidth, which is why even at 4K 30, which Motion JPEG H.265 can do, the picture quality is so much improved. So bandwidth, the bigger the number, the better. And then latency. So latency is reversed. The smaller the number, the better. So how close to real life is it? Is it delayed when you see the picture between the real transmission and the you receiving it on your TV? And as you can see there, in its most hardcore mode, which is its Genlock mode, which is when the scaler is activated as well, then you get this incredibly low latency, which does help with the switching time. Then you have Motion JPEG, which is more like your 33. So the AV over IP standard stuff is still very good in latency terms, but the H.26465 is not very good with latency. You know, you're literally waiting a quarter of a second or so for the picture to be there. But in those systems, it's not so important. And then you have your peak signal to noise ratio. So again, think about the more decibels in the system, whether that is audio or video, or in this case both, the more decibels you have in the system, the higher it is above the noise floor. So whether you're talking about audio noise, so a hum you get from an audio system, or video interference noise, these are all, in technical terms, at 0 dB. So all of this noise, so it's all hovering around there. So the more decibels you are away from this noise floor, the cleaner the signal is. So that's, again, as you can clearly see, why SDVoE is vastly better at picture quality, because the time you get to 60 dB above the noise floor, there is no noise anymore. If the system is, you know, if it's not running, the cat cable's not running too near power and stuff like that. The natural noise floor, you're so far away from it that you basically don't get any audio and video interference from the native system that we all live in this analog world. So being 70 to 100, depending on the exact resolution that's coming into it, is an incredibly good peak signal to noise ratio.
Fantastic. Thank you very much, Kev. As we're just over our 1 hour session, so I do apologise. So I'll quickly just round off here whilst Kev probably looks at some of those other questions. It's great to see so many questions coming in. I'll quickly recap. So we'll look at reasons to pick SDVoE. Then, as we said, flexibility and scalability. You can add additional transceivers or transmitters, well, transmitters and receivers down the line to grow the system when you need to. The very high bandwidth capabilities, allowing the higher image quality that we've discussed. The incredibly low latency. The control system, as we've displayed, giving you that flexibility of multi-view, picture-in-picture, video walls, etc., all done with our simple-to-use control hardware. The options of fiber or cat, again offering different price points, different transmission distances, and again that can then be beneficial for, as we'll look at here, potential applications. So you might use these in sort of high-end installs where again you need that highest image quality. Medical do tend to find these useful with the low latency and the fiber as well. And for similar reasons, military and government, again, if properties, if an installation has to use fiber because they're not allowed to use copper, then again, you've got the fiber option there, which can be very useful. Again, low latency and all the benefits of fiber and more. That's just leading us on to probably another session where we could go into more applications. But again, very flexible. Quickly highlighting again, the 1 gig system that we've spoken about, obviously very good for different applications. A 1 gig system is more cost effective, of course, and still performs incredibly well, as we've demonstrated with our IP7000 1 gig solution presentations. But again, for the customer that's demanding the highest image quality, that low latency, again, SDVoE is going to be a very good option to look at. And again, the options of fiber or cat, as you see there. And there we go. We're only a few minutes over. How are the questions going, Kev? If anyone's still with us, thank you for staying. And if you've got any other questions there, Kev, that you wanted to run through, do feel free.
Yeah, Gareth was asking what scalar chip is in the unit, and I did have it noted somewhere, but I can't find it at the moment. So it's equivalent to some of the highest scalar chips we've got. It's actually built. I don't think it's a separate IC, Gareth. To be honest, it's actually built into the SDVoE chipset, which is why it's such an amazing chipset. You know, it's designed from the ground up. Now, so there's not one I can compare it to because it is part of the actual IC chipset. But you know, the quality is absolutely superb, and it's pretty much better than anything I've seen in a separate standalone scaler that doesn't cost thousands of pounds in itself. And then Bastian was asking a little bit more about the EDID management. So it's kind of similar to what you see on most things, Bastian. So you have all the transmitters there. So showing you the sources at the transmitters, and then you have a bunch of options about, do you want to use these preset edits, or do you want to use these edits that are being received from the RXs, in other words, the attached displays. So if, for example, you have a WUXGA projector and you want to make sure that in this corporate system, when anybody plugs in their laptop to the HDMI input, it gets the edit from this, you can just map all of those TXs in that system and point them directly at the RX's output, so that they always get those edits reported back to them, so they automatically don't set themselves to a too high a system signal. What else have we got there? Bjorn, third choice button for auto. No, Bjorn, we've kind of played with this setting. This is about the DHCP auto IP, and the SDVoE system only has two things it's allowed to do. It's only allowed to do static and DHCP. So we've kind of written in this auto IP section to it, because there's no way of us being able to select that as a mode on the actual chip, because you can only address what the chip's allowing you to. But yeah, so it's something we've mentioned to SDVoE or Semtech, the chip manufacturers, actually, because we'd like to see a third mode. We'd like to see it as a separate mode. But at the moment, I'm afraid that isn't an option. So you literally, if it's a DHCP server, it will give you a DHCP address. But you could still go through and force it with a static to an auto IP address.
Wonderful.
And that was about it. Oh, hang on. What about transmitting Dolby audio? Yes, yep, you can transmit Dolby audio. So all bitstream audio is able to be transmitted through it. Obviously, digital to digital connections only.
Wonderful. I think that covers it then. If you've done all the questions, thanks, Kev. Thanks for answering those. No as everyone knows, I think again we're quite. I think we know everyone in the group, which is great. So any questions after today, obviously you know how to contact us, as on screen as well. But otherwise, I think in all the given languages, I think thank you, gracias, dankjewel, and vielen dank. I think that covers everyone in the group today.
Very good.
I hope I didn't miss anyone. Wonderful. Well, as we said, thank you for joining us today, everyone. Any questions after, let us know. But otherwise, we will speak to you all soon in the next one.
Great. Thanks, everybody. Take care out there. See you soon.